okay, or a slightly different value. Now watch carefully. Keep your eyes up for a second. This is a Photoshop image. I did a little bit of a tweaking to a photo. Did a little bit of Photoshop work over the original image, and this is the original image. Take a look. It's a mirror. Now I wanted to show it to you this way first, because it illustrates the point, the main point that I want you to remember, which is we're getting into reflections today. And the main thing I want you to remember about how to think about reflections is don't think of them as reflections. Because your eye and the light, the only thing that cares that that's a reflection is your brain. But your eye and your viewer's eye and the light itself does not treat that as a reflection. It just treats it as another object. You know, it happens to be identical and symmetrical in a mirror image, but it's the same object. You see what I mean? So all the mechanics, all of the how you cast a shadow, where the shadow goes, you just act as if the mirror doesn't exist. You just act as if the space has been doubled. All right? I was joking with the morning class. This is the one topic where it would literally help you if you thought of yourself as having a bird brain. Because a bird has no problem with this. A bird would go, yeah, it's real. You know? And that's kind of how I want you to think too, is I want you to treat it exactly as if it really exists. All right? So this again is the mirror. The only real difference is the slight change in value. Now, why is there slight change in value there? There's two reasons.
The light hits the mirror and then gets dispersed before it hits your eye.
That's half of it. Half of it is, and the main half, actually, that's 80% of it. 80% of it is the light, the mirror is reflecting light very efficiently, but not with 100% efficiency. A small amount of that light is being degraded or scattered or dispersed in the mirror. And the result of that is things in a mirror will appear just slightly darker. That's part of it. The other part of it is the light that does get to your eye, even assuming a very efficient reflection, the light is traveling farther. Because now it's got to travel from the object into the mirror plane, then to your eye, rather than just straight to your eye from the object. So it's traveling a little bit further, and there's a very slight degradation. And the degradation is equal to this value versus that value. This value versus that value. Just a slight diminishing. Now, if you had super high efficient mirrors, like the kinds they put on satellites for NASA and stuff like that, well, you'd have almost zero, okay? But a typical bathroom mirror like this one is going to be, you're going to have a slight drop in value in the mirror. Okay. Now, so in case you haven't guessed, that's what this slideshow is about. But I had to put the title slide back a couple. Now, in a way, I was talking with the morning class, and in a way, this is the perfect place for this information. Because you guys are good with basic forms, you're good with basic lights. But now we've got more than one light, because in addition to the object getting reflected, we have the light getting reflected. So these objects that are in this will act as if they have multiple light sources. Oh, by the way, I haven't said so explicitly yet, but in case no one can guess, you're going to have another rendering due a week from today. Guess what it's going to be about? How'd you guess? All right, and it's kind of the last major rendering. Yeah, it's going to be a color exercise. Yeah, just kidding. They're messing with you. All right, don't believe them.
You can believe us.
We need to make her a lot less gullible. She She's kind of like you, in fact. Okay, so if you have these two objects, there's a difference. Okay, the first object, the first light source would cast a shadow like this and a shadow like that. The second light source casts a shadow like this and like this. So you end up with a picture that appears to have two objects and two light sources. And again, as far as the photons are concerned, as far as your eye is concerned, and the mechanics, you need to just treat it as if there are multiple real things. Okay? The geometry doesn't matter, or the geometry is the same. Okay. Now, so if you add a mirror plane, basically you're adding a mirror plane here. You just need to make sure that when you do a reflection, that these objects and everything are symmetrically aligned across the mirror plane. If something is X distance from the mirror plane, it'll be X distance into the mirror plane. That's all there is. Here's the good news about reflections, you guys. This may sound difficult, this may look difficult when I'm first showing you these things, but something really funny happens. When I start showing the diagrams of how you guys do it, actually, in the morning class, this is not uncommon. In the morning class, people started laughing. You know why they were laughing? Because once I show you, it looks so easy, and it's so obvious that you're annoyed you didn't see it, and it seems so stupidly obvious. You know, and people literally will laugh when they see the way it's done. So it's very easy. Okay. Now let's take a look. So that's the mirror plane. Let's take a look at what this looks like when you photograph it. Okay. Notice you've got one shadow, two shadows, three shadows, four shadows. Because there's double the number of light sources. Each object has a light coming from either side. Notice how the tops are strangely bright because they're getting strong light from both. Whereas these are only receiving light from one side. You see what I mean? Now, here's where it starts getting a little bit weird. Okay, I'm going to move this cube. Actually, you should almost start thinking about this not as a cube, but as cubes. Okay, I'm going to move the cubes closer together to the point where they start. What would happen is the shadow would start casting up the wall if that were not a mirror plane. If it were a wall, it would start going up the wall. Watch what happens. Well, actually, before I do it, visualize what you think is going to happen. As this shadow gets close to the mirror, what do you think is going to happen? Okay, watch. Now, why does that happen? You have a tiny little triangle here that is not receiving direct light from either source. That's why it's dark. Pretty weird, huh? You guys, so the toughest part about this next rendering assignment, it's not going to be technical in the sense that you're not going to have to worry about, how to draw a cube or something like that. The hardest part is going to be conceptual, and they're like, well, wait, this would be receiving light from there. Wait, it's also getting light from there. Wait, but there'd be light coming from here. And you're going to start, I was mentioning to one of the morning TAs, and he saw the thing queued up on my computer, and he went, it's for those of you guys who know Byron, that's Byron showing a lot of emotion. He went, I said, why? He says, that one really messed me up. And I said, what do you mean? He says, I think I just thought too much about it. And that's really going to be your challenge. What do you think, Raphael? Was that a good impression of Byron?
In Shy's class, he does the same thing.
You know what's funny is I was making fun of one of the BFA students. You guys, actually, I'll tell you about this out out of turn. In the morning class, some of the BFA people came in and we're doing, and it made me happy because we're doing this drawing diagram. And everyone in the class was following along pretty well. They're all like, yeah, and they're having normal problems, but no one was totally lost. And I saw one of the BFA people come in, Peter Lee. And, oh no, it wasn't Peter, it was someone else. Anyway, so I saw this guy from the morning class come, from the BFA class come in, and he went like this, he went. And he was totally flummoxed by what it was. And I'm like, wow, these guys know a lot. You know, and then like we watched two more BFA people come in and go. Because they couldn't make sense of what they were looking at. All right, now, so we'll go a step further. You guys all understand why that's occurring. Okay? Now let's watch as we make it a little more extreme. So do you see that these shadows are overlapping? But they exist independently as if the mirror wasn't there at all. Okay, that's important. Now here's the next one. But what I want you to understand is you guys already know how to do this, but you don't know how to think about it. That's the hard part, yeah.
Is there a ratio of darkening
Nope.
to?
No, because here's the thing, that ratio stuff that you're describing, if I could describe that to you, I could give you a cube and a single light source and tell you exactly what value everything was going to be. You know, the thing is, that's actually way, I mean, you could calculate it, I guess, if you had enough parameters, but I really can't give you anything helpful to go on in that regard. It's a little like saying how hard to push on something. You know, well, don't push so hard you break it. You know, but push hard enough to move it? I don't know. Anyway. All right. So here's, I hate the term reflection. Because when we say reflection, it sounds unique. You know, it sounds like it's a unique thing. The problem is everything around us, the fact that we see it means it's reflecting light. Okay, if we didn't see it, okay, then it's not reflecting light. And there's only one thing we know of, the black hole, that doesn't reflect light. You know, it absorbs it completely and utterly. And by the way, you guys, these are simulations. These are not actual astronomical images. But what they were theorizing is, this little animation is what would happen if we happen to ever catch a black hole moving in between us and another galaxy.